Hello friends, welcome back to BitSize Machine Learning. Today we're going to continue on our end-to-end ML in 15 steps. Today's focus is on the third step, which is overview stats, explanatory data analysis. So let's get to it. First of all, let's take a look at the project structure that we've built so far. In order to do that, we use the tree function that we talked about last time. And basically you just give the directory, folder directory for your project. Mine is home projects and BitSize ML. And then this is all you have to do, and then you just run it, and it's going to give you the file structure. So mine is an end-to-end ML, and then there are 4 folders in it, and then data houses the housing.csv. And then currently this notebook is sitting at in the notebooks folder, which is the third one, overview EDA. Okay, so we are at this spot right now. Okay, cool. So first of all, in order to look at the structure of the data and then do some explanatory data analysis, we're going to first create a variable that points to this data set, and we're going to load it again. Let's now import some of the important modules. So from pathlib, let's import the path function, and then let's import the Pandas as PD. Let's run that. It's successful. Now we're ready to create a variable that points to this housing.csv. We're currently at this folder notebook, so we have to go one step up and then go down and then point there. So in order to do that, let's create a new variable called data path. And then data path is going to be equal to, using the path functions, current working directory dot parent. This will go up one folder up. And then now we are in the end-to-end ML folder, and then we can get into the data folder, and then we can point to the housing.csv. So this is our path. And then after creating this path, we are ready to load that into the a data frame. So let's call that data frame housing. Housing data frame is equal to pd.read CSV, because our file is CSV, and then let's give that data path that we just created into this. So now it's successfully loaded into this. So the first thing that we're going to do to look at the structure of this data set is using a few functions. The first very useful one is going to be, so the housing dataset dot head. So when you run this itself, it's going to just print out the first 5 rows of the data. So you can see, you can quickly investigate if the data looks correct, how many columns that you have, they all look fine. So if you want more, you can just give, for example, I want to look at the first 10 rows, you can just enter 10 and then run that. So it's going to give you 10. Similarly, you can do the last few rows using the tail function, and then it's going to give you the last 5 rows, for example. As you can see, the index is 20,639. If you want the last 10 rows, you will just enter 10, and it's going to give you the last 10. So everything looks fine so far. So the next thing I want to do is let's take a look at the entire structure of this data set, which we're going to use the info function. So when you run it, it's going to give you a very nice summary of your data structure. So the range is from 0 to all the way here. So we have 20,640 entries. And then we have 10 columns from 0 to 9. And then you can also take a look at the names of those columns here. And then the non-null column is very useful to take a look at if we have missing values. For example, the total bedrooms column seems to have some missing values, and everything else is the total count. So that's useful as well. And we can also take a look at the data types column, which shows the columns data types. For example, from the longitude all the way to median house value, all these 8 columns or 9 columns are all float 64 data types, which is numerical, and we can do mathematical operations on these. However, the last one, the ocean proximity, is not. So it is an object type, so we cannot do numerical operations on these. So this info function is very powerful, and then it will give you the entire structure of dataset, and it's very useful for investigating your data. So the next one that I want to show you is the describe function. So let's do housing.describe. The describe function, when you run it, it's going to give you the statistics of the data distributions of statistics of the numerical columns only. So as I said earlier, from the zeros, this longitude all the way to median house values, they're all numerical. So because they're numerical, we can take a look at those statistics of those. For example, the counts, how many we have, the mean, the average values, standard deviation, min value, max value, etc. So the describe will grab all of these numerical columns, and then we can take a look at the numerical distribution of those columns. So as you can see, the last column is median house value here, and we're excluding the ocean proximity, which is not a numerical value. So the describe function only looks at the numerical columns, and it will give you a nice statistics of count, mean, standard deviation, min, and max. So that is very useful. So if you want to take a look at the object, which is not numerical columns distribution and what is in there, we can take a look at as well. And then we are going to just use housing, this data frames, this last column. You just give the name, ocean proximity, and we can do value counts function to take a look at what is in there. So we have 5 categories in them, 1, 2, 3, 4, 5, and then each one is counted. So this less than 1 hour ocean, we have 9,136 values of this, and then island we only have 5, and nearby bay 2,290, etc. So it will give you a nice distribution of the non-numerical column using this way as well. So this is how we do the most basic explanatory data analysis using Pandas. So in our next video, we're going to further analyze the data by splitting the data into training and testing data sets. So stay tuned.